Hello students, welcome to Eduauraa. My name is Nipun Bhatia, your physics mentor. Today we'll be starting with the topic Induced EMF in a rod rotating in a uniform magnetic field. So let us first draw the diagram according to the condition of the question. Now here I am going to consider a uniform magnetic field, something like this. Now if this is a uniform magnetic field, it is having a magnetic induction of capital B bar. Now here I am going to consider a rod, something like this. I am going to say the rod is pivoted at this point. So this is a pivot point, that is O. So if this is the pivot, the rod is actually rotating along the pivot. Okay, so it is attached at the pivot and the rod is rotating something like this. It can go in an anti-clockwise direction or it can go in a clockwise direction. We are going to consider that the rod is moving in an anti-clockwise direction. So if rod is moving in an anti-clockwise direction, the velocity which is applied on the rod is V. Now I'm going to say here I'm going to consider a small element, that is dr. If I'm going to consider a small element, that is dr, the distance of this dr element from the pivot O is r and the total length of the coil is taken as L. So as coil is rotating, the linear velocity is V, but as it is rotating, it is going to rotate in a circular form. As it is going to rotate in a circular direction, it is going to attain an angular velocity, that is omega. Okay, so as it is moving, it is going to move with an angular velocity omega. Now, how to find the value of induced EMF? I know the value of induced EMF, or the basic formula of induced EMF is E is equals to BLV. That is, E is equals to B into V. If I am going to consider the small element, that is dr, I will be saying BV into dr, and due to the small induced EMF, that is dE. So dE is equals to BV into dr. Now as dE is equals to BV into dr, I am going to say V is equals to R omega, because the linear velocity should now be considered in the term of angular velocity. So at the place of V, I am going to substitute R omega. So dE is equals to B into R omega into dr. Now what exactly I have to do? I have to find the total induced EMF in the coil. If I want to find the total, I am going to say integrating above equation. If I am going to integrate the above equation, it is integration of dE is equals to integration of B into R into omega into dr. Now when EMF was 0, initial position was at pivot, that is O. The total length of the rod became, that is L. Now here magnetic induction B is constant, omega is constant. What is changing? The distance R. So integration of dE from 0 to E is equals to B into omega, integration from 0 to L, R into dr. Now the basic rule of integration is upper limit minus the lower limit. E is equals to half B omega L square, and that becomes the final answer for an EMF induced in a coil rotating in a uniform magnetic field. So students, I hope you are clear with the entire concept. For more such videos, stay tuned to Eduauraa. So be happy, keep learning and keep watching Eduauraa.